we're going to look at the relationship between the chords and arcs of a circle. So our first theorem tells us that two chords are congruent if and only if, IFF, they are equidistant from the center. The equidistant is the perpendicular distance. Keep that in mind. So I labeled the circle, so if you're taking notes, you can do that. Circle O, segment OE is congruent to segment OF. And because they're congruent, and it is the perpendicular distance to the chords AB and CD, then what we know is that segment AB, chord AB, is congruent to segment CD or chord CD. All right, so basically if we write it as a conditional statement, if segment OE is congruent to segment OF, and it's a perpendicular distance, okay, to each of the chords A, B, and CD, then we can conclude that those two chords A, B, and CD are congruent, okay? So let's look at the first example. We have circle S, and we have that LM is 16, so let's get another color here. We'll make this 16 from L to M, okay, 16. And NP is, or PN is 4X, right? But what we don't know is anything about the arcs, but we do know that from S to Q is equal from S to R, and it is a perpendicular distance. So therefore, we can conclude, okay, not assume, but conclude that segment LM is congruent to segment NPN. Now, we know that 16 then, as its measure, is equal to 4x. So x is equal to 4 by dividing, okay, and we can find that. So that's the relationship from the perpendicular distance from the center to a chord. If they are equal, the chords are equal. What's really cool, it leads us into our next theorem, okay, factual information, is that if two chords are equal, then their arcs that belong to them are equal. So here we go. So in this case, since NP and LM are congruent chords, then their arcs LM and arcs NP would also be equal. And then remember, that would be in degree measurement as opposed to length. Okay, so let's take a look at this. So here's our next theorem. I did label here, so I made the circle O, A, B, C, and D. So if you're taking notes, again, you can relabel with me. If two chords are congruent, so if segment AB is congruent to segment CD, then their corresponding arcs are congruent. So writing this up as a conditional, if segment AB is congruent to segment CD, okay, then we can say that the measure of arc AB is equal to the measure of arc CD. That's a C. Or we could just say that arc AB is congruent to arc CD, implying that the measures are equal, okay? So if we want to find in our next problem the length of chord AD, what we need to know is something about the measurements of the arcs. We see that the measure of arc AD is 56 degrees. The measure of arc CB, or BC, is also 56 degrees. So when I'm doing these, even, marking, I'll even mark those congruent if I needed to, just for a visual. But I always put my writing of my degrees on the outside of my arc so I can see that. So that's going to mean that these guys here are equal. Okay, so these would be equal. So the length of AD is going to be congruent to the length of BC, so AD's measure is going to be 30. Okay, it's as simple as that. So there's a nice relationship between chords and arcs. All right, so let's look at a couple of problems, more algebraic, of course, so that we make sure we can handle those without a problem. All right, so what we have here is we have two arcs that are congruent. Okay, so this is telling us that the measure of arc MN is equal to the measure of arc PQ, or you can say the measure of the congruent of arc PN and PQ, all right? Which means that our chords are congruent, which means their measures are equal. All right, so we go right for it. 3x plus 5 equals 26. Find x. Subtract, subtract. 3x equals 21, so x equals 7. All right? And then, you know, for your check, plug 7 back in. That's 21 plus 5 is 26, and they should be equal. All right? Okay, now, chords don't always have to be separate, okay? They could be, you know, attached, forming an angle. This angle here, ABC, actually would be called what we call an inscribed angle. We'll be tackling that in a little bit. But this chord BC has an arc of 85 degrees. And this chord AB also has an arc of 85 degrees. So therefore, the measure of segment BC is going to equal the measure of segment AB. So they're both in algebra expressions. So we're going to add appropriately on each side. And we're going to get 4 equals x, so x is 4, and you found the value of that. Now, what about the measures of the segments? So CB is 4 times 4 plus 3, so 16 plus 3 is 19. And then I guess I would check AB also just to be certain I didn't make any kind of calculation errors. So plug in 4 for the x again, and we get 20 minus 1, and again 19. So the measures of your segments can be calculated as well as whatever missing variable there is. Okay? All right. All right. Now, last piece of relationships between chords and arcs is perpendicular bisectors. Now, the longest chord in a circle is the diameter. All right, so just FYI, it splits your circle into semicircles, or each arc is equal to each other, all right? So, and each one of them, of course, would be 180 degrees. When a line coming from the center of your circle intersects a chord, then it bisects the chord and the arc, okay? So you don't have the whole diameter here. You could have a circle. I know that's probably more of an egg, but you could have a line, a radius, coming from the center of your circle, perpendicular to a chord. That's all you need to know. And it will split that chord in equal parts, and it will split your arc into equal parts also. That belongs to those chords. All right? So that's what this means. Sometimes you might not even see the whole radius, so you're going to have to use your noggin. All right? You could possibly see just this. Coming from the center, perpendicular to a chord, means it splits that chord into equal parts. And if it were to continue, it would split the arc. But sometimes we don't necessarily need information about the arc. All right? Okay, so let's look at our example here. We have a diameter right here. It goes through the center of a circle. We can see that it's defined as our center. All right, and this is 15.7 on this side, so this is also 15.7 from point here to the end point of this, the line segment on that circle. All right, we know that this is 12, and we want to know what this is, because the line drawn from the center of our circle perpendicular to our chord splits our chord into equal segments. This 5.6, it's there to mess with your head. It's just this little tiny part of that line that comes through and intersects your chord at 90 degrees. So since this is 12 and we want to know that, this is also 12. Okay. All right. Now, if our arc from here to here was 80 degrees, then each one of these would be 40, because that would also be split. So just an FYI in case you hit problems where it's asking you about the arc measures. Now let's look at this next problem. From here to here, the radius is 10.9. We have a line coming from the center of our circle perpendicular to our chord, which is here. This part of our chord is 9. This part is x. So what's x? Well, because this comes in perpendicular, it splits that chord in equal parts, so x is equal to 9. All right, if we wanted to know what this was, okay, don't get too fooled. You can get caught up in this a little bit and, oh my God, what is it? Remember, it's a radius, so it's 10.9 also. Okay, if you needed to find out what this is, now you can use Pythagorean theorem and you can find out this little piece right here. The whole thing from here to here is 10.9, and then you'd be able to subtract to find this other little piece. So there's a lot of information given here. There's a lot you can do with it. So as you encounter different problems, pay attention to what information you have. Please draw out your circles and put all your information on it. Make them big enough so you can write on them, not these little tiny things. And then label everything. And once you write on it, you will see it kind of come to life, and you'll see what parts you have and what you'll need to get to find the rest. And that is our relationship between chords and arcs.